Today's lesson, we are looking at topic 8, which is electricity production and the environment. So burning fossil fuels or burning fuels, we've seen that in thermoelectric generating plants, fuel, oil, natural gas, coal, they get burned in the large thermoelectric generating plants to produce electricity. These fossil fuels, they are non-renewable resources, meaning they are getting consumed faster than they can be replaced. Fossil fuels are being used up, they're being consumed faster than they're being produced in nature. When we talk about renewable resources, they can be replaced or replenished in less time than it takes to draw the supply down. So things like biomass, that's considered a renewable energy source because it can be continually replenished. Here we're just looking at a generator here, or thermoelectric. So heat from burning coal, it's going to convert water into steam. That steam is under high pressure. It's going to flow through pipes, and it's going to start spinning this turbine, which will then turn this generator, which will then produce electric energy. Steam will then leave the turbine to be cooled, condensed, and then it'll get recycled and get reused again. And then here we see our electrical energy. Turbo generators, they use exhaust gases from burning fossil fuels to spin a turbine, which is coupled to an electric generator. Therefore, no steam condenser or cooling tower is required. In Alberta, some natural gas production facilities, they generate electricity with turbo generators that are fueled by flare gas. Flare gas is a waste product from the facility. Here we're just looking at a map, sources of electricity in Canada. This is just showing like a pie chart of sources of electricity in Canada. So hydro, thermoelectric, thermonuclear, combustion turbine, and then internal combustion. So here in Alberta, our largest is thermoelectric using fossil fuels. And then we have some hydro and some combustion turbine, some internal combustion. Okay, so just looking at a summary of steps that convert the energy stored in coal to electric energy and then to light a lamp. So firstly is mining the coal. Mining uses relatively little energy compared with the energy that's stored in the coal that's produced. About 1% of a typical mine's coal production would supply enough energy to operate the mine. The rest, the 99% of the mine's energy output, is available then for other uses. Next, we have to transport the coal. So move that coal from the mine to the power plant. That's going to use some energy to power the train. The efficiency of transporting coal is about 97%. Next is generating electricity. So thermoelectric generating plants, they're not very efficient. Most of the energy from the coal escapes from the stacks or from the coolant water as heat. Only about 33% of the energy from the coal that is burned is converted into electricity. Next, we have to transmit or transmission of electricity. Travel, it has to travel through the power lines. Some of the energy goes into heating the conductors. So that's about 85% efficient. And then finally, we have to convert that to light. We talked about incandescent light bulbs. They're very inefficient. Most of the electric energy gets converted to heat. So an incandescent light bulb is about 15% efficient. Next, just how fossil fuels affect land and air. So coal is the most common fuel for thermoelectric power plants in Alberta. So there's serious environmental side effects. like pollution and so forth. Open pit mining of surface deposits disturbs soil and vegetation. This is when mining in which the fuel, like coal, it's uncovered and dug directly from the ground. So those kind of open pit mines, those are going to affect the land, the water, the wildlife. This picture here is showing an open pit mine. It was the Cheviot mine near Jasper. It has been abandoned because of protests by environmentalists. There is a waste material called tailings. These are underground mines. They produce this waste material called tailings. It accumulates near the mine. It's a type of rock waste from the mining industry. Water is used in the mining process or seeping through the tailings. It can become acidified and contaminated. And then when fossil fuels are burned to generate electric energy, those contaminants will escape from the smokestacks, all right, and contribute to pollution. Electrostatic precipitators can remove most of the solid particles, but they cannot remove contaminating gases such as sulfur dioxide. Sulfur dioxide, we talked about, is one of the causes of acid rain. It harms plant and animal life. We talked about scrubbers. Scrubbers are systems that can remove sulfur dioxide and contaminating gases resulting from burning of fossil fuels. They basically spray a water solution through the waste gases. Most of it, but not all of the sulfur dioxide and other pollutants can get removed. Carbon dioxide, even if there was no contaminants like sulfur dioxide, the complete burning of coal or natural gas is still going to produce carbon dioxide gas. So even though carbon dioxide is a natural part of the atmosphere, right? Every time we exhale, we are breathing out carbon dioxide. But carbon dioxide, it is a greenhouse gas. It delays the escape of heat from Earth's atmosphere. And if there's too much carbon dioxide, methane, and other greenhouse gases accumulating in our atmosphere, it's going to absorb more heat from the surface of Earth. And that is what is leading to a rise in the average temperature of Earth, which is global warming. Natural gas, however, does burn much cleaner than coal. It does produce less sulfur dioxide. Hydroelectric plants, these are the ones that use water pressure to generate electric energy. So large dams can cause the water level to rise high above the power plant. It's often located inside the dam, and then as the water depth increases, the pressure at the bottom becomes large, and then water flowing under great pressure is then used to produce electricity. So I think this is the image here. Here, water is being held here. Energy is therefore stored in the reservoir because of the tremendous mass of water, and its height is usually above the base of the dam. And then here we have the turbine that's going to spin and the generator as well, which are going to convert that stored energy into electric energy. This is just a channel here called a penstock. It'll direct the water from the bottom of the reservoir to this turbine. High pressure of the flowing water will turn those turbines, which will then turn the generators. And then it'll be converted to electric energy. And then we see the transmission lines, which will carry that electricity over many kilometers from the hydroelectric plant to the cities, towns, and farms. So these power plants, they appear to be very clean form of electric energy generation because they don't have smokestacks. They're not using any radioactive materials. But keep in mind, there's always some cons, right? The reservoirs, they can flood many hectares of valuable land, homes, small villages, towns. They may have to be removed, which are going to displace people, industries. animals, other organisms. If land is flooded, submerged vegetation starts to decay, and then microorganisms that are responsible for that process, they're going to use up oxygen supplies in the water, and then they start to produce methane gas. Methane gas is another greenhouse gas. All right, so that decaying vegetation matter starts to produce that methane gas. And then those conditions make it impossible for some species of fish to survive. And then algae and other forms of life, they may take over. They're going to change the ecosystem. So dams, yes, there are pros to dams, but there are also some cons. Some form of life is threatened with these hydroelectric power plants. I'm going to pause here. We'll watch this video. All right, next we're going to look at energy coming from atomic reactions, so nuclear fission. So bombarding uranium atoms with tiny particles called neutrons causes uranium to split. That's what fission is. Nuclear fission is to split atoms. So it causes the uranium to split into two smaller atoms, and from that, a tremendous amount of energy is released. So this type of fission reaction, it produces a tremendous amount of heat, which will then be carried away from the reactor core by a coolant. Pipes will carry the coolant through a tank of water, producing steam. The steam will then turn a turbine connected to a generator, which will produce electricity. That steam will then leave the turbine, it will get cooled, condensed, and get recycled, and any waste heat is then released into the environment. So here is a thermonuclear electric generation station. This is a CANDU reactor. It's the Canadian deuterium uranium reactor, which produces electricity from nuclear energy. So these are designed and built in Canada, and they've actually been sold around the world. All right, so let's pause and take a look at this video. All right, so fission reactors, they don't release any soot or gases that cause acid rain, nor are they releasing any greenhouse gases, but the used reactor fuel, it's highly radioactive for thousands of years. It's emitting high energy particles and rays that can damage living tissues. So safe handling, transportation, and storage of these radioactive waste materials are still unsolved environmental problems. The reactors themselves also become radioactive after years of use, so they are also difficult and expensive to decommission. All right, so next, nuclear fusion, as we saw in the video, it doesn't produce large quantities of radioactive waste. So in the sun and other stars, nuclear fusion, it's joining very small atoms to form a large atom. And then huge amounts of energy are released in this process. So scientists, they have been able to produce controlled fusion reactions experimentally, but only for seconds. So fusion is not used. It is nuclear fission that is being used. And like we saw in the video, there is a lot of waste produced with that radioactive waste. So heating the environment. So all thermonuclear and thermoelectric generating plants, they release thermal energy into the environment. 70% of the thermal energy from nuclear fuel and 43% from coal, oil, and gas, it leaves the plant in the cooling water. So thermal pollution, this is when that warm water is returned directly to the lake or river from which it was taken. It'll increase the water temperature. So even a change of a few degrees, that can start to affect the plant and animal life in the water. Organisms that have adapted to one temperature, they won't be able to survive at another temperature. So, and then organisms that aren't usually found in that lake or river, they may begin to replace the original species. So to reduce that thermal pollution, these large generating plants, they have cooling ponds or towers where that wastewater has to return to the temperature of the surroundings before it gets released. Cogeneration, these are systems that produce electricity and also supply thermal energy, such as hot water or steam, for industrial or commercial heating. So basically the plant provides electricity and heat or steam to the industry. And then if there's any excess, they'll sell excess electricity to the provincial power grid. An example is the Poplar Creek Power Plant near Fort McMurray. It provides electricity and heat needed to extract oil from the tar sands, and then it adds any extra or excess surplus electricity to the Alberta power grid. So therefore, it's reducing the amount of energy wasted, reducing the dependence of large industrial power users on the Alberta electricity grid. This reduced demand, it'll make it easier to make the electricity needs of the rest of the province's consumers. Alternative energy sources, as our fossil fuels are being consumed and depleted, they're becoming more costly. So energy from the sun, wind, and tides, which until now has been too expensive or too difficult to harness, it's rapidly becoming competitive with conventional energy sources. So wind energy, wind turbines are used to supply green energy, electricity generated in an environmentally friendly manner to power the grid. It's feasible where the average wind speed exceeds 11 kilometers per hour, common in southwestern Alberta. Wind-driven electricity generation has to be used together with other electric energy sources or storage devices. So here, wind turbines are generating electricity, which powers the C-Train equipment in Calgary. Okay, so next we are looking at solar energy. So solar farms, they seldom use solar cells because they're expensive, they're fragile, they're converting only about 15% of incoming light energy into electricity. So instead, the alternative method of harnessing solar energy is to use it to heat a liquid. That hot liquid will then flow to a generating station. It will boil water into steam, and that steam will then turn the turbine and electric generator. And solar energy devices, they only work when the sunlight is reaching the collectors. So as a result of that, these storage batteries are required to supply electricity at night or in cloudy conditions. And then in sunny conditions, those batteries can be recharged. This is in California. Reflective mirrors in the California solar farm are curved precisely to concentrate solar energy on oil-carrying pipes. Okay, so next is tides. For example, here, the generating station at the Bay of Fundy, it traps tidal waters that have come in at high tide, and then it uses the energy of the water as it flows out of the bay. Another design allows the station to use the energy of the water continuously, first as it flows into the basin, and then again when it flows out of the basin. Similar to hydroelectric generating station in a dam, as the water that has been trapped in the basin flows out, the water pressure then turns the turbine blades that will then turn the electric generator. I believe, lastly is geothermal energy. So the hot inner parts of Earth contain a great deal of thermal energy. That's called geothermal energy. In some areas, Earth's crust has cracks or thin spots in it. Groundwater is then able to flow down from the surface, absorb thermal energy, and arise again as hot springs and geysers. Steam that's produced by geothermal activity can then be used to rotate the turbines and then turn the electric generators. Heated groundwater may contain dissolved sulfur compounds. So condensed steam from the turbine is often pumped back underground to reduce pollution. And then only certain places on Earth have the proper geological characteristics to use geothermal energy. So for example, Iceland, it's located on a boundary of two tectonic plates, and it's known for its volcanic activity. In Canada, Other forms of energy are more available, like coal, oil, gas, and it's easily accessible. So use of geothermal energy sources has been limited. All right, so I'm going to pause here